Swayam Prabha. Digital India. Educated India.
Hello everyone and welcome to this demonstration through these GIS softwares. So, I am in this discussion or in demonstration we will have demonstration about the concept of no data, which we have already discussed in few classes back, and we will see practically now what is the meaning of basically no data, how it is handled by the software, and the second thing which we are going to have discussion in or demonstration about the different map projections. And I will try to use two softwares, how they handle this map projection, but concept wise it is same as we have discussed in the theory part, and that we have to sometimes change from one projection to another, and changing vector data from one projection to another is rather easier or relatively easier as compared to the raster data, because raster data when we project from one projection to another, there might be introduction of no data, and that too we have to handle little carefully, but otherwise it is not a big problem, and most of the good softwares have already implemented different map projections and also custom design. So, if you are having required parameters about your projection and you do not have any standard menus, still you can project your data from one projection to another. And one other important thing about map projections, nowadays most of the softwares also use a concept which is called on-fly projection. That means that if you are already has opened your software and having one map in the background. For example, I am having a boundary or countries map of the entire world. Now, after that, when I will add another theme in my project, which is maybe in different map projection. So, my first theme is suppose in UTM, another layer I am going to add is part of India, which is in polyconic projection. So, when I will add this one, automatically the second layer will get the same projection as of the previous one or the first one. So, this kind of concept is called on-fly projection or fly-through projection. So, as soon, but it has to be projected. Both themes have to be projected. Whatever the first theme, the second theme will follow the projection of the first theme. And this is what the concept of on-fly projection, which is very, very useful, and it becomes very convenient to keep adding data or different layers, themes in your map. So, good practice is always to always use that map or display or add in your project, which you know that this is the projection I want of all other themes. So, whenever you keep adding new layers, new themes, automatically they will adopt the map projection of the first one. So, it is a very good help in real projects to imply this on fly. Basically, you do not have to do anything except that the first theme has to be chosen very carefully, which is already projected. So, now we will see demonstration on the software. Okay, so what we are seeing here is a digital elevation model which is covering entire India and neighboring countries as well. Now, this digital elevation model, as you can see here on the table of content, it is USGS topo of 1 kilometer resolution. Now, someone may think that what is the use of 1 kilometer spatial resolution digital elevation model. But through my own experience, it is very, very useful. First of all, it is useful from the map projection point of view. I want to because it's not a very big file, I want to keep as a background, and whenever I want to use, I can use it or just keep as a background, and because it is satisfying my projection requirements. Otherwise, it is also very useful for some other purpose whenever I want to show anything of say India. So, if I am working over India, I can definitely keep this tile of 1 kilometer resolution. And if I want to go for a higher spatial resolution digital elevation model, like here, which is a 30-meter ester based digital elevation model, no problem. This is what you are seeing, a 30-meter spatial resolution digital elevation model. But before that, what we will do, I will zoom a part and then will show you the what is the basically difference between these different spatial resolutions. As you see that at now this is what it is being displayed as 1 kilometer spatial resolution, and this is called USGS topo. This is very famous. You can also download for your area of interest, and if you are working for India, then one tile would be sufficient for downloading and covering the entire India. Now, here individual cells are representing 1 square kilometer of the area like here, and if I zoom it, I can get the exact elevation value for my this one also. So, only thing I have to choose little carefully that only the visible layer, and then next time when I click, I get the value which is 2371, you know, or this is stretch value. So, you keep ignoring the stretch value, the pixel value is the real elevation value, which is what is useful. You also might be knowing, this will also come in future discussion, but since we are having demonstration, so I will briefly touch this USGS topo. This USGS topo global digital elevation model has been developed employing 250,000 survey topo sheets of various countries, and the contours of from these 250,000 scale topo sheets have been digitized, and employing interpolation techniques, a global surface has been created at 1 kilometer resolution. So, at very early, maybe like 10-15 years back, when we did not have any other global digital elevation model, then we used to imply this USGS topo 1 kilometer resolution digital elevation model very extensively. Now, since we are having digital elevation models available at 90 meter like SRTM, no issue, we can very well download for our area of interest, or 30 meter, or even nowadays you can get a 12 meter. For India, you can get also cartoset based digital elevation model of even up to 5 meter resolution. But there are only few tiles for India it is available. One other important thing one has to really remember is when we say high spatial resolution or low spatial resolution, so relatively here we can call this USGS topo relatively is low spatial resolution digital elevation model. But there is advantage of relatively low spatial resolution because only one tile, because this has been developed in form of tiles. So, you need not to download the entire global file, you can just download it a tile of your area of interest like I have done for India. But being a relatively low spatial resolution, it is covering a large area, not only India but even surrounding countries. So, in that way it is very, very good if my application requires to cover entire India and surroundings. But if I want a higher spatial resolution DEM like the one which I mentioned here about ester one, then it covers a very small area of India, and small tiles would be there, and depending on whether they are 5-degree tiles or 1-degree tiles, you can definitely check. If I put my cursor on the corner and read at the bottom, longitude it is 78 degree, and this is again, so this is 1-degree tile. And same I can check for latitude, that if I keep here, this is say 30 and this should be 31. Also, if you read the name of the file which I have downloaded, also clearly tells us that what is the extent of this tile. It says that north 30, that means latitude wise it is represent starting this corner one, this corner bottom left coordinate is north 30, that is latitude, and E for part of that is longitude of eastern hemisphere. So E078, that is means the 78. So if this is always addressed to the bottom left corner. Similarly here also what it says for India, if I again and zoom it this one, what I find that here just to check the longitude I have to, because here the lower part is mixing with the background. So here it is 60 and also it is and then it should be 40 or here this is 40. So likewise these tiles are addressed as per their latitude, longitude, extent. So very well you can very easily know which one is the degree tile, which one is a 5 degree tile, or which is a much more wider tile like this one. Now what we are going to do, we will now focus mainly on this ester one, and before I go for this no data thing, which is for this demonstration is specifically, first I would like to tell that it is always easy or it is always possible to create a subset of your data set, whether it is a vector data or a raster data. What we are going to see here, if I want the the digital elevation model of this ester DEM of only this red polygon, that is my say watershed or my area of interest or a district, doesn't matter. And I do not want to keep any other thing except digital elevation model for my area. So it is possible to employ a tool, and you can always search also here that you can just type like extract raster or clip, extract raster, and just say and then extract by polygon. So when you choose appropriate options which are there, you get immediately a clipped part like this one. So this belongs to this watershed which earlier we have formed, or it is there. So likewise it is very easy to clip for that area or extract for that area without any problem. These tools are available in all good softwares. Now this is so this is the first step in that sense about for the no data. Now what you are seeing here is arbitrary boundary of a digital elevation model, whereas I have been always telling that overall shape of a raster can only be either square or rectangular. Of course, the cell value, shape of the cell or unit of the cell, unit of raster is always square, but overall shape can only have either rectangular or square. But here I am seeing in arbitrary form, which is only for the display purpose. So if I go in the properties of this one, then I would find that the node concept of no data is being utilized here or being employed here. That is what I have discussed also. And here the no data is given as no color should be displayed. Display no data as nothing, and therefore it is mixing with the background. For time being, if I change the color and I say okay, display as a yellow color, then it will display. So the true shape of my overall raster of this clipped watershed or subset of my ester DEM tile is this much, which is including yellow areas. But since I have instructed to the system that do not display as any color, no color, and then say apply, now the color is mixing with the background. If I know that the background color is white, so I can also choose white color, and then still there will not be any changes. So it is always better to use no color and say apply. So whatever the background color doesn't matter, your watershed or your area of interest will be displayed with arbitrary boundary, but the system knows as a two-dimensional matrix, and that can have either rectangular or a square shape. So this is very, very important for no data. Other things if you want, you can definitely handle, but whenever you make a extraction or clip of your data, that will be always displayed. You can by default this particular software will assign the no data as without any color. So it makes our life much easier to do such kind of things very easily. So this is what is the no data is doing. Now another advantage of no data is that whenever I am using no data and it is declared to the system, then that value is not considered in any of my calculation. So that is another very good part of no data concept, that for any calculation, even for statistics, no data values are not considered at all. That is why you are not seeing the no data value here. The elevation values are between 573 meters to 2895 meters. Whereas no data values are generally given in default by minus 4 times 9 or 5 times 9. That means it doesn't, this kind of value will not exist on the surface of the earth. The deepest part on the surface of the earth is 11 kilometers. So, and highest part on the surface of the earth is 8848 meters. So, if my no data value is either lower than 11 kilometer or higher than 8848, then, and if I declare as a no data value, then system would know very easily. So this is the technique which is employed for no data, and it makes our display much more realistic rather than always displaying the area of my data with a different color. So here if I use a color, then it doesn't look very nice. But if it suits your requirements, you can definitely display your values without any problem. I have earlier also mentioned this hillside. So just very briefly, I will also discuss this hillside part also. But this hillside discussion would not be complete once we discuss the theory part. And after that theory, again we will come and how to generate hillside, what are the precautions or options we have to take, that I will discuss later. But related with the no data, I would like to discuss this hillside. So here again, this is a SRTM 90 meter of Himachal Pradesh digital elevation model. Again there is a arbitrary boundary, and the background is, or the no data value is having black color, which we can check also here. See, no data is as a black color. Again if I choose no color, it will disappear, and it looks now much more realistic and good also. Rest of the areas are mixing with the ground. That means the no data value. So whenever you encounter such problems, try to handle these things through no data. And as I have already told you, once the no data has been declared, that value is never used in any kind of calculation or estimation or statistics. So that value is always ignored by the software. And here what you are seeing, a hillside which has been derived using digital elevation model, and that hillside has been is shown here as a colored one and not a zoom. Now, sometimes we find some other requirements. So, I will just show you a very simple way of achieving these things by implying the same data differently. So, first I add a file which is called which is the one which I showed in the theory part also, very common file which I have been using. This one is a digital elevation model. Hillside has been derived from this digital elevation model, so which I will also add in my this view, and this sorry, hillside. So, now I am having one is hillside, this is elevation, flat, only it is grayscale, no other values are there. Minimum value is 94.7, maximum is 370 for this entire area. Whereas this hillside is being represented as 0 value and 25 because it is a 8-bit image, but it is giving you the feeling of the terrain. Now, this one we can call as a digital terrain model, and this one we can call as a digital elevation model. But believe me, this terrain model or hillside has been derived using that simple digital elevation model. That means this one has been used, and one very popular derivative, that is hillside or shader relief model, has been derived this. Now, the one which I wanted to show a very simple way of bringing both together and making a very useful product for further use in our plotting or analysis. That what do? You keep this elevation grid higher in the priority than hillside. That means hillside in the background and this elevation model or DM on the top. And here I will change this ramp or color palette into a more attractive color, something like this, and apply. So, now what is happening, that the gray, instead of gray shades, now I am in colors. Now, further thing which I will do here, that in my display I will make this the color digital elevation model 50% transparent. And see what happens as soon as I press apply button. See that the background in which I have a hillside in gray is now entire, both layers when are displayed together, the top one 50% transparent, the bottom one is fully opaque, then this is the product which I get, which is a very useful for several kind of plotting. It is not only giving the colors, but also giving the feeling of the terrain, or it is terrain surface in that sense, or we also call as a relief map. So, very easily, without any involving any classification or other thing, you can create a shaded relief model or hillside from a simple digital elevation model and display top of first is a elevation file, and then that hillside file, and give colors to the elevation file or DM, and also 50% transparency. And once you do it, you get this kind of product. Now, we will be also discussing about the map projection. So, let me also show that one to map projection. Here what I am having? I am having two files or two layers. One is just countries in no projection or in geographic projection, and the values are appearing here in degree decimal, and as you can see that the shape of Antarctica is completely distorted, whereas the countries in the center are okay. But as if you go on the higher latitudes or near the North Pole, as like in South Pole, the country's boundaries are completely distorted here also. So, now this is about how to change this projection to another projection, and that we can do. Another layer which I am also having in my view is this UTM zones of different countries. So, if I zoom over say India, this there is some issue about the boundary of this in India in the northern part because of some international dispute. So, that we can ignore here. This is not the true boundary of India in the northern part, but many international maps are showing wrongly. So, just ignore that part, but say if I want to check the what is my zone at this part. So, immediately I can know the zone and that visible layers, and when I press here I know the zones as well. Now, what I am going to do, I will project this one using different projections. So, what you can do that you say data frame properties in this particular software, and then you can choose a different map projection. A whole list of map projections are available, starting from Geographic to our custom designed also, and various projections are there as discussed in theory class, that each country is having their own projection system. So, if I say projected coordinate system and I want to display and say polar projection, now for within polar projections there are many. So, say I want for north or this north pole, or I would go for south pole projections, and these are the details which are being used while changing from this projection to another. And once I press, just see what happens to the maps, how it is changes to the chosen projection, which is south pole stereographic projection. See, so now the word is being shown, and see this is now true shape of Antarctica. So, when I am seeing from the bottom, means from the southern pole upward, having a stereographic projection for south pole, this is what the true shape of Antarctica. Whereas in the earlier that was not that was absolutely a complete different representation of your Antarctica. The similar, if I go and say for Asia, and here I can go and change for say for example Indian projections, and these are the details are there, and you can, if you want, if you are having further information, you can definitely change it, or you choose this one. So, as soon as I will apply, you will see things will change and they have come live. So, this is how now see the shape of Antarctica completely gone bad, whereas the shape of other countries is now okay. So, it depends on where that particular country or your area of interest is there. Further, I also said that if you want to do some measurements, then the best thing is first to project to UTM. And let me do for India. Say if I choose a UTM projection for India, say 46. There are different zones which I wanted to show you earlier. No problem. Here we will see. So, if I choose this 46 zone 46N, N stands for northern hemisphere, apply it, and then this is what now India, roughly India is in the center, rest are going here and there, and this is zone 47. If I go for 48, then there will be some again changes like this, or I can also go for 44. Indian 44 is not there, but anyway. And also you see here that this is of course transverse Mercator projection, and you would have easting northing or false easting northing, and the central meridian is 93, and there might be some change in scale also. So it is very easy nowadays, it has become, to change your data from one theme or one projection to another without any problem. You can change to any projection whichever you want. Like suppose for northern hemisphere WGS 84, again I can choose the zone say 44 as I was looking for India. Alright, apply, and this is what now India is in the center. Sometimes I want to show the true shape and size of India only, rest I do not bother in some projects or in some work. Then I can choose that particular zone, and automatically that will come in the center, and rest may be distorted. As you can see what happens to the Antarctica, Australia or South Africa or in northern hemisphere. Rest has gone except for India. It is a correct representation. And likewise, so if I zoom, I get the correct representation. And so this is how you can project both data sets, vector and raster, from one projection to another without much problem. The problem only with raster data, that whenever you project from one projection to another, it would create a no data value also. So once it has created, not a big issue, you can assign no data value as no color, and just remember, whenever you encounter no data value, assign no color. So it will mix with the background, you won't see, everything would be alright. After georeferencing also of raster data, it would create no data. So the best solution is assign no color, and that way it will mix with the background, and it would look more realistic and nice as well for presenting them either through PPT or some other like printing or other things. So it is always better to handle these things. That is why I have discussed or demonstrated these two things together, because whenever you do or change from one projection to another, you are going to create no data, and whenever you do the georeferencing other things, so no data and map projections in some way they are links, and choices of map projection nowadays is enormous, and custom design projection systems can also be used for as per your requirement. You can modify any existing projections as well, and some favorite you can create like this one, and this is GCS, and WGS is World Geodetic Sprite 1984 projection, Geographic Coordinate System. GCS stands for that. If I apply, I get perfectly, and now I am getting values in degree decimals. So this is what from where I really started our discussion. So with this I end this demonstration with the advice or request that please spend some time not only practicing about no data, getting feeling of no data, how to handle no data, but also try to do map projections. If you want these like layers or files for on your system, very easily you can find on the net. Just type the bird countries boundary or download, and probably first or second link will take you to that one, and then try to project this theme using different projections. There will not be any problem. The same way I can also do it in ArcView as well. Though it's a older software, but doesn't matter. The same data I can take, and I can So this is the file which I was having. Now here also, when I go for this properties here, view properties, and then I can change the projection. Currently it is showing my mapping units are degree decimal and my distance units are miles, doesn't matter. I can convert into say kilometers, no issue. And for projection, currently it is saying no projection because it is geographic coordinate or GCS system. So I can change a projection. Here in this software you may not get those number of projections as in ArcGIS, but the other part here, if you are having your own data to create your own projection, custom design projection, then you can do it here very easily. Only it requires the reference latitude, central meridian, two parallels, two standard parallels, and false easting and northing. So these 6 parameters are required. You can choose a whichever you want, like Lambert conformal conic, or which is more close to our earlier polyconic Lambert polyconic projection. You can use a spheroid and then you require these parallels. Currently I do not have these values with me, so whatever the default it is displaying I will choose, and let's see what happens. So when I apply, I may not get anything on display, and doesn't matter. So sometimes there might be some problems. You have to really try with different map projections, and hopefully these will work. In the standard parallels, probably the parameters which we have chosen were not correct. And like if I go for Mercator projection, and these are the values which are being taken, projection of the world, I can say projection of the hemisphere, or I can say UTM. So if I go UTM, here I can choose India. The 44 roughly comes in the center of India, and that from zone point of view, and I say OK and OK, and now I get UTM projection 44 there. And of course my latitude longitude values here in the top right corner are in meters, because these are in easting northings and they are in meters. So this is how the system will automatically change from one projection to another. Now see what happens to the orientation of Australia or Antarctica. Completely distorted, but India is in quite a good shape and size. So if shape is good, of course it is going to be the correct size as well. So with this I end this demonstration. Thank you very much.